Hello, my name is Francis Ozier. I'm a senior biochemistry major. I'm looking to mentor Chem 102 for my 8th and final time so that I can continue to support students, engage with the content, and make sure that they continue to be passionate about learning chemistry.
How do we find the pH of a solution when a solid mass of an acid is added to the volume of water? Well, first you write an equilibrium reaction. So acetic acid plus water is in equilibrium with acetate and hydronium. Now, it's in equilibrium because acetic acid is a weak acid and does not dissociate completely, so there will be some reactant and some product remaining in the final solution. This was a simple synthesis in acid and water. Water acts as the base and accepts a hydronium, the conjugate acid. And acetic acid, of course, acts like an acid and donates a hydrogen, which is expressed here with the loss of the hydrogen in the conjugate base. And so we're going to set up an ice table. Now it's important to always have phases listed when you have a reaction, because here we can only use aqueous solutions. Solids and liquids aren't really used for ice tables, and gases could be used, but that's for another time. So that's why there's a giant X where water is. Now ice stands for initial change in equilibrium. Since we're trying to find the pH, and pH is the concentration of hydronium, we're trying to find this X. And so we get started. But in an ice table, everything needs to be in molarity, or at least here it does. And we can't do that with 5 grams at 200 milliliters. So you have to do some dimensional analysis, as shown here, to get 0.42 molar acetic acid. And then what? So for the change, since you can't get a negative molarity for the substance, it's gonna increase. But by what? We don't know. And also, since it's all 1 molar, or not 1 molar. Yeah, since it's 1 mole of each, it goes up by 1x and it goes down by 1x instead of 2 or 3. And at equilibrium, we're gonna have pretty much 0.42. Normally it would be minus x, but since acetic acid's a weak acid, then we're gonna make the assumption that that x will be negligible, and I'll get to that later. And then these will be x. So we're gonna find x using the expression K equals the concentration of the products, which are multiplied by each other, over the concentration of reactants. You can see here we find what x is in molarity. Now, there's something called the 5% rule, which states that if the final concentration, which is x, is less than 5% of the initial concentration of the acid, which is 0.42 moles per liter, then you can ignore x, and you can ignore subtracting x because it's going to be canceled out with significant figures. Also, keep in mind we're working with 2 significant digits for now. And so that's x. But how do we get that to pH? Oh, but x is the concentration of hydronium. How do we get that to pH? Well, just by doing negative log of hydronium, which is the expression for pH. Now notice here, it's 3 significant figures and not 2. Well, that's because when you're taking the logs of something, significant figures isn't the same. Instead of keeping it the same, you just do the number of decimal places is the number of significant figures you used to have. So this is how we found the pH to be 2.56.